Welcome to Learning with Philemon. In this video, we will be looking at the mole and Avogadro's constant. There are many words in the English language that represent a quantity. For example, a pair means two. You can have a pair of gloves. A hat trick refers to 3 goals in football. You can buy a dozen, 12 eggs. A century, 100 years can pass. In chemistry, such a word also exists and is called a mole. If you have 1 mole of a substance, that means it contains 6.02 times 10 to the 23 particles, atoms, ions, or molecules. This number is called Avogadro's constant. To learn more about how it was experimentally determined, check out the science notes link in the description. To get an idea of how large this number is, you can imagine that if you had 1 mole of softballs, you would fill a sphere the size of the Earth. 1 mole of Olympic shot puts that weigh 7.26 kilograms would have approximately the same mass as the Earth. Because in chemistry we are dealing with moles of atoms or molecules, the mass and size is minuscule. The moles, N, the mass, M, and the molecular mass, Mr, are related by this equation. N is equal to M divided by Mr. Note that in chemistry, grams, G, are used for the unit of mass. The molecular mass is determined by adding the atomic masses, found on the periodic table, of all the elements in a molecule. See the previous video in the playlist for more help on calculating Mr. For example, the molecular mass of water, H2O, is 18. The units are grams per mole. This means that if you have 1 mole, or 6.02 times 10 to the 23 water molecules, they would weigh 18 grams. This is approximately 18 milliliters of water. You will often be asked to calculate the moles, the mass, or the molecular mass. You can rearrange this first equation so that the mass or the molecular mass are the subjects. You either need to practice rearranging these equations or memorize these 3 forms. Here are 3 example questions. In the first question, we need to determine the number of moles in 132 grams of carbon dioxide, CO2. At this point, we only know 1 variable in the equation, mass. However, as we know the molecular formula of the compound, CO2, we can determine the molecular mass. This is equal to 44 grams per mole. Substituting the mass and the molecular mass values into this equation, you get the following calculation. There are 3 moles in 132 grams of CO2. Note that the gram units cancel out. In the second question, we are trying to calculate the mass of 0.2 moles of magnesium, Mg. As we are dealing with an element, we do not need to calculate the Mr. We can simply find the atomic mass on the periodic table, which is equal to 24 grams per mole. Multiplying this by 0.2 moles, we get 4.8 grams. Note that the units of mole cancel out. In the final question, the molecular mass is unknown, but the mass and the moles are known. Substituting the values into this equation, we get the following calculation. The molecular mass is 58.5 grams per mole. The compound in question must therefore be sodium chloride, NaCl, as it has a molecular mass of 58.5 grams per mole. Thank you for listening. To consolidate your learning, try to answer the questions in the description. If you haven't already, please subscribe for more content. Stay curious.